All right, so I'm just going to show the whiteboard. Okay. So in class, we had already discussed kind of how to solve some of the equations and how to show your full work. And it's okay. I was going to say it's okay if you can use if you want to use your calculators for that, but you're not going to have them. If you guys want, what I will do is I'll put the answers. I'll put the answers for each of the questions. And it's up to you guys to show your work and prove the answer. Okay, so if the answer is x equals 3, then it's up to you to show the work and see why the answer is that. Okay, does that sound good? So let's see. Okay, so remember that in this situation, if you look at the, let me just draw something out really quick. If you look at the right side, or sorry, the left side, it's not simplified, but then the right side is okay. So just focus on this left side right here. And what we need to do is that we need to simplify by combining anything that's a like term. So we have 3x and then we have 1x. And that in total it comes up to 4x minus 1. Okay, so now that we have that was a terrible line. So now that we have that, we can start our process by moving things around. So let's try and move around 4x. So we would subtract 4x on both sides. But if you notice what happens here is that we cancel both of these out. So we're actually left with -1 equals 7, which of course, that's not true. -1 is not equal to 7. So what would be our solution here? What are we ending up with here? If anyone
No
can answer.
solution.
Yeah, exactly. So that's a no solution. So that's the way that you would prove something that is no solution, right? Because we've been doing it in the calculator. But basically, what happened here is that both of our x's canceled out. So we were left with just constants. So we only had -1 and 7. So we were left with no solution there. And I think there is 1 or 2 in the homework that are no solution. So I want you guys to prove it and see why it is no solution. All right, let's see. And of course, how we had discussed the other side. So if we said -2x plus 4 plus 8x plus 5. Okay. So again, if you notice the right side is simplified already, so we can, ignore that for now. And let's just simplify the left side of this. So what are the things that we can combine here?
2x and 8x and 5
So
and
yeah, 2x and 8x and 4 and 5, right? So that should be 8x minus 2x, which would leave us with 6x. And then we have 4 and 5, which would leave us with 9. Okay. So that's about it. Now, let's look at the other side. And what do we notice about the other side?
It's exactly alike.
It's the exact same thing, exactly. So what this tells us is that whatever number we decide to plug in for x, it's gonna work no matter what. So if they're the exact same thing, what kind of solution do I have here?
Is it a no solution
No, I mean,
or
in
just click
this
with the
case,
0?
because in this case, no matter what we put in, so let's say I'm gonna plug in 1, right? Then that would be 6 plus 9 on both sides, 9 plus 6, which would equal 15 on both sides, which is true, right? Or I could do, let's say I were to plug in 2. I could do 6 times 2 is 12. So 9 plus 12 on both sides. And that's 21 on both sides. So if you notice, it doesn't matter what I plug in, all of them work. So what kind of solution would that be? Remember, there's 3 types of solution. There's one solution, there's no solution, and there is what? That's the last one.
Is it an equal solution? Like, 'cause I forgot what the solution was.
Infinite.
Oh, okay.
There we go, right? Infinite, meaning that any value of x will work. Okay. And when we start graphing, we'll see a little bit about how this works and why it is the way that it is. Okay. Okay. Let's see what else. Okay. So we'll stop there for now.